So you might say, how do two hobbies like aviation and amateur radio get together? Well, before STEM was a thing, and that's a long time ago for me, in 6th grade, we launched a model rocket. And it just bit me and bit me hard, so I became very, very engaged in loving aviation and aircraft. My career never allowed me the opportunity to actually get involved with aircraft. I somehow, as an engineer, avoided Boeing and McDonnell Douglas. It just never happened in my stack. I was fortunate enough to work underneath one of our members here, and that's Joe Flegel, who taught me quite a bit. So I appreciate that experience. My primary work focus throughout my career, though, was on technology. And about 4.5 years ago, I retired after 40 years of engineering and IT jobs and said, okay, what am I going to do? I was pretty sure that I didn't want to just sit and watch TV all day, so I needed to find something. And I said, volunteering's the way to go. And the place I found to do that was at, Wings of Hope. Wings of Hope helped me develop new skills. I had not touched an aircraft prior to the day I walked into their facility. And as you might expect, they were a little bit suspect. Here's this guy who the questions you get asked there are, what did you do at Boeing? I didn't work there. How long have you been a pilot? I'm not. So what the hell are you doing here? So, but I also felt that it was a great opportunity to help other people in the world. So I'm going to spend a few minutes pitching Wings of Hope here a little bit, in that I think they're a good organization. As all organizations go, every organization has some challenges, and they're no different. But overall, they're really a good place to be. They're based out of Spirit of St. Louis Airport, and they have two primary missions. Their tagline is changing and saving lives through the power of aviation is what their tagline is. And so they support medical air transport at no cost to the patient out of St. Louis here. So we fly 3 different aircraft, 2 Senecas and a Navajo. And if you meet the qualifications and the territories and spaces, they'll fly you for free. We've had patients, Children's Hospital here, Shriners Hospital here has a couple of programs that some of the children have flown 15 and 20 times with us to come back and forth from wherever they may be. Kansas, got about a 600 nautical mile range on our Senecas and an 800 nautical mile range on the Navajo. They were founded in 1963 by a group of philanthropists here in St. Louis, one of which was John Fabic of Fabic Tractors. He was one of the original ones. And they've been twice nominated for the Nobel Peace Prize. So the medical air transport, as I said, is free for qualifying patients and 1 caregiver. All 3 of our aircraft are stretcher capable, 800-mile radius on the Navajo. We do occasionally pay for commercial flights as well, particularly if we have a flight operations problem and somebody's stuck somewhere. We may have to fly them back, but we've given that commitment that we're going to take care of them, so we do. And all the pilots, nurses, and patient advocates are all volunteers, as is, there's over 300 volunteers in the organization. So the other part of us is the Global Humanitarian Network. We support mission activities, medical mission activities, primarily in these countries. And the focus of this project I got involved with is to add Guyana in South America to our mission sites. We supply technical assistance, we supply aircraft parts, we supply logistics, all kinds of things to these various locations to help people out in the world. One of the biggest things the people out in the outside world need air transport for is snake bites. If you're in the middle of nowhere and you get bit by a snake, you got some serious problems. And so the pilots out there do quite a bit of snake bite carrying. The Ghana mission we're talking about, or Guyana, I always mispronounce it. Guyana is located in northern and southern South America, so it's right next to Venezuela. There where the Am I going to get a mouse on here? There it goes. There's one country between them. So right here in the middle, on the eastern seaboard of South America. It's the third smallest country in South America, so it's really pretty small. One of the least densely populated countries in the world. There's not a lot of people there, but they're made up of 9 different indigenous tribes. So there's communications problems, there's lots of dead space between the tribes, so there's a lot of space for an aircraft to cover. As you can see, it's a pretty long country north to south. So that presents some challenges for them, and the reason they got us involved. So the question might be, why do we need aeronautical HF? Yeah, because that country's long, north to south. We're blessed in America with very good VHF coverage throughout the country for aircraft radios. But as hams, we all know a little characteristic of VHF, right? It's line of sight. Pretty close. Well, line of sight at 5,000 to 6,000 feet is still pretty decent, but it's not the 300 or 400 miles long that country is. So air traffic control does use HF to cover parts of their country that they do not have VHF coverage on. In fact, it is still recognized in commercial aviation the need for HF radios on international over-the-water flights. Remember a few years ago that aircraft that disappeared? They didn't have it on radio communications because it was outside the range of radio communications. And that's why, because VHF only goes so far off the shore. That aircraft was way off the shore. Perhaps they had an HF. There is some movement towards satellite phones for aircraft, or satellite communications, but the FAA still only recognizes HF communications with the exception of emergencies. So it's a little bit of a controversial area there, because our first approach to solving this problem for them was, let's just get them a sat phone. It's simple, it's easy. It sits in the bag, don't have to use it unless you need it. Well, there was another little problem there, and that's that the villages that are being served have HF radios in the villages. So that is a means of communication back to the headquarters of these mission services is through HF radio. So after we talked about it a lot and tried to figure it out, we reluctantly agreed to put HF in an aircraft, a small aircraft. The large aircraft, it's not a problem. There's lots of space to put an antenna on a large aircraft. And you can afford to buy very expensive antennas on a multi-million dollar aircraft. So we don't have that luxury. So before we go too far, I want to go over what a little bit about the avionics is. And the word avionics comes from aviation electronics. Avionics. So aircraft have 3 primary electronic systems in there. The voice communications, and the standard band for voice communications is 118 to 136.975. It is AM. All of our stuff on VHF, let's say, I wouldn't say all of it, but we all think FM when we think VHF, unless you're doing small signal or things like that. This is all AM, and there's a very important reason they chose AM for aircraft. It does not capture. When you call into the repeater on FM, strongest signal wins. Well, it'd really be a problem for you if the guy close to the airport's talking and getting directions and all of a sudden you're calling in an emergency and nobody can hear you. So the folks who put aircraft radio systems in place in the 30s and 40s said AM is the way to go, and it still has stuck all the way through there with great reasoning. They are 25 kilohertz space signals. There is some movement over in Europe to go to 8.33 kilohertz, but right now in America it's still 25 kilohertz. And they are channelized. You can't just randomly dial up a frequency in the aircraft band from your aircraft and talk on it. You have to go to one of the specific channels. All the aircraft radios are indexed. They're just channel, 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 channel. The next part of it is the navigation systems that are in aircraft. VOR is what they use to find out where they're at in space, or where they're at on geography. So VOR stands for Very High Frequency Omnidirectional Range Station. Yeah, think about that 5 or 6 times. Ew, that's a mouthful. Well, it's a very complex radio signal, and if you've ever driven through the countryside and see something out in the middle of nowhere that looks like a pointed dome, and it's got all kinds of spikes around the side of it, that's a VOR station. So that is a station that's giving navigational information to the aircraft. It puts out 2 specific signals. One of them is consistently at a specific frequency, and then the other one circles around it and changes the phase in relation to that main signal. And that's how an aircraft can find out what heading it's on. So when you're flying, you set your receiver up for a specific VOR frequency, and then the system says, okay, I'm at 214 degrees to that VOR. So if I fly 214 degrees, I'm going to fly right smack over the top of that VOR. And that's how we've navigated since the 1940s. GPS is changing that quite a bit, but there are many, many, many thousands of VOR stations across the country. They have started discontinuing some of them, but that still is the way that a very stripped-down aircraft can navigate, is with VOR. The other one is, of course, GPS. Now, until I started working on aircraft, I didn't realize how many different GPS systems are out there. I always thought there was one. But there's not. There's like 4. There's Russian-sponsored ones, European-sponsored ones, ours, and ours are on 2 different levels. There's one called WAAS, Wide Area Augmentation System. And that's what gives the aircraft the precision they need to like feet differences on their approaches. So they can fly into an aircraft or into an airport knowing from just their WAAS signal exactly where they're at, height and space. So that's why GPS is important to them. Just wanted to kind of give you an overview of all those technologies within an aircraft. There's a lot of things happening radio-wise in aircraft. Of course, there's lots of other instrumentation in there for engines and other things that don't really impact the radio world. So our project, the HF for Guyana, started off with a conversation with the pilots who are going to be flying the missions. And we've quickly found out that those frequencies don't even come close to any ham bands. But fortunately, most of the amateur radios that are out there today have a back door in them that you can open up the transmits. When we first started talking about it, we said, okay, well, I'd really like to buy a radio that's been opened up already so we don't have to go in there and take the chance of somebody saying, oh, you screwed around with this, your warranty's void. Not that a manufacturer would ever do that. So being the naive person I am, I call up Yaesu. And I said, hey, I see at the various resellers that they offer Mars signal opening on it, and that will open up the frequencies available. How do I buy that radio from you? Oh, you can't do that. That cannot happen. Our radios are only FCC certified. You cannot do that. Okay, then why do your resellers offer it? Well, that was called legal cover. As long as they don't admit it, and they can stick their head in the sand and said, hey, somebody messed with that radio, it's not my problem. So we did find out, and we found that these 6 frequencies were well within what we could do with the radios we were looking at. The other design criteria was the radio had to have the ability to operate for a short period when the aircraft was on the ground. They don't want to operate as a base station with it, but they do want to have the ability to have just a few minutes of conversation to follow up with somebody if they need to radio back to the hospital, something of that nature. And you don't want to power up the whole aircraft because when you're in the middle of nowhere, all you've got is that battery. And that battery doesn't last long when the engine's not running. So we had to offer some methodology for them to power up just the radio. And it had to consume a minimal amount of space on the aircraft and not significantly impact the weight. Aircraft weight is gold, particularly when you're trying to bring people back that are injured. You've got a finite amount of payload that you can put in that aircraft. This particular aircraft has about a 1,500-pound load capacity. That includes people, fuel, and anything else you can put in there, medical supplies. Now bear in mind, fuel weighs 6 pounds a gallon. This aircraft holds right at 70 pounds of fuel, or 70 gallons of fuel. So you've got a lot of your 1,500 pounds gone right off the top if you get that thing fully topped off. So there's lots of concerns in making this thing work. So we were very fortunate that on the Wings of Hope team, we have multiple hams. Gary Liu kind of took the lead on this. He's been a ham for a long time, does a lot of digital work here in the area. Mark Amon is another gentleman who worked for Joe. He and I met each other while we were working for Joe. He started on helping us with this project. John Gala is another volunteer at Wings, and myself, and then Steve Tompkin is our Wings of Hope avionics manager. And so he just kind of oversaw and listened to all of us talk and stand in the corner and babble, as he would say. But he was wise enough just to get the heck out of our way and process the paperwork.
Tell him we'll have a tech class in February.
Oh, I've talked to him several times about that. Yeah, I don't let anybody off without talking about it. Just ask my friends. So this is the aircraft that's going to be going to Guyana. It's a Cessna model U-206 Bravo. It's a really young airplane. It was only manufactured in 1966. I was talking with Brendan here as we were getting started. At Wings of Hope last year, we had an aircraft we were working on, and we were all marveled that it was made in this century. That's the only aircraft I've ever worked on at Wings that was made in this century. All of our aircraft there are old. And in general, the general aviation fleet is quite old. This aircraft, excuse me, has a 285 horsepower 6-cylinder engine with a maximum airspeed of 182 knots. At 183 knots, the wings fall off. Not really. But that's considered the not to exceed airspeed for that aircraft. Typically, it's about 135 to 147. Yeah.
So what's knots converted to miles per hour?
About 1.2.
Okay. 200.
So this particular aircraft, Wings of Hope obtained in the late 90s, early 2000. I wasn't able to obtain the exact date, but it had crashed into a lake in Kentucky. They found out about it. They recovered it. They originally bought it for parts, but when they got it back and started looking at it, it was good enough that the mechanics were able to rebuild it and make it air safe. It has been flying ever since then. So it's got quite a history on it. It has been deployed to a mission previously, so I'm not sure where that was at, but it's gone and come back. So this is the interesting part of an aircraft panel. That's the pilot on the left, of course, and the co-pilot on the right. The various instruments. In the center here, where's he at, Bouncy? Right here, is what we call the radio stack. So that is where all the electronics happens at. These guys are what tell you where you're headed towards those VORs. So they give you directional guidance of where you're supposed to be heading. The rest of it I'm not going to get into because it really doesn't relate to aircraft. If you want to talk to me individually about it, I'd be happy to. The radio stack is the heart and soul of what I get involved with, though. And this is a better picture of it. Excuse me. The top unit is an altitude set for the autopilot. The second one down with all the little buttons on it is an audio switcher. So it allows you to route the information from any of the radios to your headsets and your microphone. The next one down is a GPS, so you'll see that later on lit up. Next one with the 2 screens is a comm nav radio. The comm radio is on the left-hand side, the nav radio is on the right-hand side. The empty tray is something called a transponder. It was out for service while we were working on this aircraft. But a transponder is what tells the FAA what aircraft you are. When it gets hit by the radar pulse, it responds back with a specific number, and the FAA assigns you that number. So when you're flying, they'll give you a 4-digit number, and that's what you enter into that item, and it responds every time the radar hits you. So that's how they track who you are. Down below there is an engine monitor. The round circle is an engine monitor. But that whole space down there, we had to take over in order to put the HF radio in there. We took that little engine monitor and moved it to another open hole on the panel and confiscated the rest of that panel space for the radio and some controls we were putting on it. So what we chose was a Yaesu FT891 and an FC40 tuner. As you might imagine, with frequencies as varied as those are, it'd be really tough to get a resonant antenna. So we were definitely going to need a tuner. And the reasons we chose this equipment was it's relatively lightweight, had an easy frequency mod on it, didn't have to cut any traces. It was just basically jumpering out a couple of places. Had a great integration with the external tuner, so it had the direct control lines on that tuner. And it was cost effective. Being a volunteer 503c organization, money is always top-notch important. So we had to look, I mean, I'd have loved to put, flex radio or something in there, but it'd been a little bit overkill. And also the pilot has to be able to operate that while he's flying a plane. So it's got to be simple to operate. I mentioned before about needing to have the thing powered on while it was on the ground. So we put together a strategy to do that, which is what's represented in this drawing. So aircraft have an avionics bus, which is only turned on after the engine is running, because the engine cranking takes a lot of current out of the battery and puts a lot of noise on the bus. So we don't want the radios active when there's all that chatter going on, high voltages, low voltages, all kinds of junk on the bus. So that's what this bottom indicator is down here. This is the avionics bus. This guy here, the PM6000, is the audio panel, that panel that had little buttons on it to route the signals to the headsets. And then we have the FT891 and the FC40. So what we did is we brought from the battery bus through its own separate 25 amp switched breaker, so it's a breaker switch combination, and went straight to the FT891 and the FC40. And then we tapped off of that with a 2 amp feed, which is all it takes to run that audio panel is 2 amps. And we diode isolated that from the avionics bus. So that way we can power that audio panel so they can listen to the radio on their headsets anytime they bring up the HF radio, even if you're on the ground and the rest of the aircraft is not live. So that's how we power managed it. And of course the drawings told some folks how to install it. So the other challenge was, how are we going to get that audio signal in and out of that radio, microphone, and earphones? Well, aircraft radio have a little bit different impedances and settings. So you notice it says original audio interface. As I looked at the specifications for the FT891, and I looked at the specifications for the radio, the regular VHF radios, and I looked at the specifications for the audio panel, everything just perfectly seemed to line up. It was 600 ohms, it was 8 ohms, the levels were about right in the couple of hundred millivolts. Everything looked good until we put it together. So we ended up having to punt on this. After consulting some of the manufacturer of the audio panel, actually, the guy laughed at me on the telephone, said, yeah, that's why we make this interface box, because it just doesn't work without this. Oh, by the way, this interface box is $750. So right now we're sitting there with the regular handheld mic plugged into this radio. The audio is working well to come through the headsets, but the problem came with the mic. When we keyed the mic, everything just went weird. If we keyed it through this system, it's all kinds of bad noises. It wasn't RF feedback, which is what we initially thought it was, because we could take the mic and plug it straight in the side of the radio and everything worked fine. So we punted for now, and we've just got the mic plugged in, and we're going to do some flight testing with it to see if that works or not. We'll find out. But this is absolutely proves the old adage about assuming. It got me good. Physically, the FT891 is about a 1/4 inch wider than the racks the normal radios go in. When you consider the U-mount bracket, U-mounting bracket and the bolts that hold that U-mounting bracket on, yeah. Without the U-mounting bracket, it fit right in the tray perfectly, but I had no other way to mount it. So what we ended up doing was taking the tray above it, which was that blank tray, and we mounted a little top or bottom plate on it, which is this piece of sheet metal here. We manufactured that in our own shop, and put another plate on it that coupled into the feet mounting, the mounting holes for the feet that go on the bottom of the radio. So we were able to anchor it that way so it holds in very well. You're guaranteed to run into these things when you do this kind of project. There's going to be something there that doesn't quite fit.
Can the radio breathe?
The radio can breathe, yes. We positioned it in such a way that the side vents had space through the sidewalls. We tried to pay a lot of attention to that, although we don't expect it to have a very strong duty cycle. Okay, if you want to get into a wiring mess, open up an aircraft. That's what it looked like in the middle of doing this project. That blue handle you see down there at the bottom, that's the throttle for the engine. So that's just looking straight up the stack. As you can see, we've pulled everything out of there. The engine monitor that I spoke about that we moved, it was in this panel down here. It went right there. There's lots and lots of wires back there to deal with. And if you really want to have fun, that looks like an open, that's an easy access right there. A lot of times the way you access that is from the floor underneath that panel. Think about going underneath the front panel of a Volkswagen. Look at me, folks. I'm a big dude. These shoulders don't fit into some of those spaces. So it gets me quite interesting doing it. But you always find your way. We have to be very careful with coax. All the GPS signals have to use RG400 as a minimum. The transponder, the thing that replies back to the radar, it puts out 100 watts in a very brief duty cycle, but you're getting 100-watt bursts through that coax. So you got to pay a lot of attention to coax routing and signal wiring, or else you start getting a lot of interesting feedback. So the antenna tuner, it got mounted to the ceiling of the aircraft. The top picture there is the antenna tuner mounted at the top, and you can see that little aluminum plate there. That's the top of the aircraft, right? Get my mouse to bounce over here again, right here. And that aluminum plate is a backing plate. The skin of the aircraft is only 32 thousandths thick. So you can't put anything on it unless you stiffen it. So in order to reuse a previous hole that was in the aircraft top, we stiffened it up and put the feed through for the antenna there. So that's just the one end of a long...
Hold those volume keys for 3 seconds to use TalkBack.
Hello. It's configured as an in-fed long wire antenna, is the antenna configuration. The aircraft itself is the counterpoise. And that tuner, then the wiring for the tuner comes down, where'd my mouse go? This side panel, side mullion here on the side of on the co-pilot side of the aircraft, and then in underneath the panel. That's a little bit of fun. That headliner there was put in 1966. To say it's frail would be being kind. And they stretch it over teeth. So there's barbed teeth around the rails, and you stretch it and like putting carpet down in your house with the tack strips. You stretch the carpet into the tack strip. Same thing's happening with that headliner. You're stretching it into teeth. So it can be a little bit interesting if you take too much headliner down. Okay, there's another picture of the antenna tuner from a side view. You see up here is where the feed through went through. Straight wire. We wanted to get the antenna tuner as close to that feed through as we could, just simply to minimize the radiating antenna inside the aircraft. And also to make sure that we were clear of any control surfaces, because that aircraft has control wires that go overhead to control the ailerons and the flaps. So you sometimes have to be very attentive to sliding wires. Those control wires are much like the speed throttle on your lawnmower. You got that round tube with just another slide going through there, the old speedometer cable. Yep, that's what's controlling those aircraft. So it's very interesting. So the antenna. So where in the world do you place an antenna on an aircraft? It's quite interesting. As we researched it, there's really two types of antennas that are viable for HF on an aircraft, and that's a shunt antenna. Well, shunt antennas really look very attractive because they're small. They're basically a stick that hangs underneath the aircraft. However, they're also extremely expensive. That's the type of antennas that are on F-18s, Boeing 747s, Airbus 380s. So, they're designed for people who can pay a lot of money for an antenna. That's not us. So that left us with a long wire, which will work fine. It works fine on HF. It's just, there's something about hanging an antenna on an aircraft that makes me a little nervous. Now, that obviously is not our aircraft, but that's exactly how the antenna routes on our aircraft. It comes out of the top of the fuselage, where you saw that feed through in that last picture. Comes out the top, goes up to the vertical stabilizer, then out to the left wing. Believe it or not, that's 60 feet of antenna wire. So you got a nice long wire antenna. You got a pretty nice counterpoise. The aircraft's pretty good hunk of metal. My concern, and the concern of all the rest of the team, was sustainability of that antenna in the slipstream of the air. Company that makes it is called Dayton Granger. Now, we're used to paying, what, a couple $100 for a long wire antenna kit? I mean, and that's being generous, I think, right? Most of us will go get a hunk of hard-drawn copper and wing it from there, right? Well, try $1,000 for that antenna kit. And the real secret sauce is in the spring-loaded attachment features. That's where the cost came in on it. We also were not very happy with this little guy right here, which is what they have for an attachment point on the wing. So we looked at that a little bit stronger. There's what it looks like when it's attached to the wing. Well, the challenge in general aviation aircraft is that little cup on the end of the wing is made out of fiberglass generally. And it's attached with 632 screws. Each one of those screws going along there is a 632. They're spaced, what, 8 to 10 inches apart? Yeah, we weren't really feeling the love associated with flying that at 150 knots. So we went forward and we redesigned that attachment point, putting some additional screws through the wing into the attachment point, a nice bent heavy metal. I believe that was 60 thousandths aluminum that we made that out of, and attached it. The shock absorber is this guy right here, and that is a spring-loaded shock absorber. You can see a little bit of a ball joint right there, and a clevis pin to hold that on, so it can wiggle around in the wind as it wants, and everybody's comfortable now that that's got a pretty good chance of surviving. One of the reasons we want to be really sure it survives is if that pops off, where's the wire going to go? It's going to trail behind the aircraft, right? What's on the back end of that vertical stabilizer on an aircraft? The rudder. You get that wire tied up in that rudder, it's not going to be a very good day for you. So we want to be really sure. One of the things working with aircraft, we put a radio in our car. We think about fusing it so it doesn't let the smoke out. We do something on an aircraft. Every screw we turn, every bolt we put in, we think about how could this kill somebody. Because you're at a couple thousand feet up there. You don't got a lot of time to react to it, and you don't have a lot of options. AAA is not going to make a service call on the side of the road. So it's a very important thing to pay a lot of attention to, how things anchor and where their failure modes can be. What can cause them to fail? And that's why we put those, I believe those are actually drilled through 1032s with lock nuts on them to anchor that. I didn't actually, Gary and Mark and John were the ones. I want to give those guys more credit than I have so far because I was involved mainly in other projects. I did some of the design work on this and was involved in the team, but they were the nuts and bolts guys. They were the ones who did all the work putting it together. And I wish they could have been here tonight. They were all invited, but each one of them had something else going. Unfortunately, none of them are members of our club, but I'm working on that. So that's the, there's the final installation. You can see the panel here. This is the 25 amp breaker switch. That's the 2 amp breaker that was that separate diode feed to the audio panel. And these are 2 other little switches, other little data ports that were in that panel that we had to replace. So we just moved them to the new one. And here's our dangling mic right at this point in time with a really custom-made mic holder, but it works. Unfortunately, the whole project got stalled. Seems as though the politics in Guyana got to be a little bit interesting, and the pilots have been unable to get clearance and approvals from the government of Guyana to move forward with the development of this mission. They're hopeful that it's a 6 to 8 month delay. However, every aircraft also has a requirement of an annual inspection. 366 days and that aircraft is grounded from the last time it was fully inspected.
Don't you have to do 100 hours on these?
You do have to do 100 hours also. This aircraft hasn't flown but like 10 hours in the last year and a half. So we don't have to worry about that. But we do have to worry about the annual. Whether the aircraft flies or not, 366 days from the last time somebody made a logbook entry completing an annual inspection, it's grounded. Well, we ended up grounding this aircraft about the 1st of August when we were ready to start doing flight testing. Because of the uncertainty of Guyana and our lack of our need to fly this aircraft right now, the organizations decided to sit on the annual inspection. Makes good sense. Why do you want to inspect something now? So you get only thing you need to do is do some radio test flights, and then 6-8 months from now they want to fly the aircraft out of here. Well, they fly it out of here, and 3 months later they got to do an annual inspection on it down in Guyana. So they're sitting on it waiting, and we're going to do an annual on it a month before it's supposed to leave, at which time we get reactivated and say, does this thing really work? I was hoping to be able to come in here tonight with audio of actual HF aeronautical communications, but we got grounded before that.
You can run it on the ground.
Oh, we have. We have run it on the ground. My major concern is an aircraft cockpit is an extremely noisy environment. I'm very nervous about what that mic's going to do in that environment. So that's why I was trying so hard to, because the mics that are on the headsets are noise canceling, and they're really close talk mics. So if you get them this far away, you get very little audio into it. You got to really close talk them, and thus the noise level is quite low. I'm worried about that. We're going to see how it turns out. On the ground, it worked great. Mark had a couple of local QSOs on it.
So don't even think about using the speech processor.
No. it'll get a little bit funky there. All that impulse noise. Yeah, you got the engine firing. Let's see, this thing. These engines run at about 2,700 RPMs at cruise. So, yeah.
So the air traffic controllers in Guyana, do they speak English or Spanish?
I believe they're Spanish.
Yeah.
That's not my problem. I'll tell you, I'm not going to be going down there to do the annual.
Your radio will speak Spanish or English.
Yeah.
Whatever I put in it, yeah. But yeah, the pilots are all, actually the pilots, one pilot's from Canada and 2 are from Great Britain. 2 of the 3 have already been missionary pilots in Guyana. So they're familiar with what's going on down there, and they're trying hard to get through this political challenge. So, and then,
Challenge just around the HF radio? Or
no, the challenge is their operation as a whole. Yeah, they're, one would think that a country that has wide-ranging challenges with their people for services would encourage people to come in and help them. Not really. The governments there are just kind of blind to the people in their need. They are definitely, we complain a lot today about a government for the people, by the people. Yeah, they don't even have a concept of that down there. So this is what it looks like when it's all lit up. The top is the,
Oh, got to plug it in.
okay, we're going to say okay real quick, because that is my second to last slide. Top is the audio panels where you select. The middle, the blue one in the middle is the GPS, and that's just the startup screen of the GPS. Then you have your comm nav radio. The transponder is now in there. On this one, that 1200 is where the transponder is at, and then our FT891 underneath it. So I appreciate you taking time to listen to me tonight, and I really do hope that sometime in the next few months I'm going to get on the net on a Tuesday night and say, hey everybody, we're going to be doing an HF Aeronautical Mobile at 1300 on Thursday. Tune in if you can. And you get to talk to some of you. Has anyone ever done aeronautical HF? All right, nice.
By accident on a net, a guy was, he was landing in Topeka, Kansas, and it was a 10-meter net, and he had a radio in the aircraft.
Cool, cool. Yeah, your range is incredible at 5,000 to 6,000 feet. On VHF, yeah. I was actually kind of hoping the one gentleman that's part member of the club that's a pilot was a commercial pilot. Doug. Yeah, I was kind of hoping he'd be here tonight. So, but anyway, I hopefully you can join in. Yes, George.
So what kind of power do you run out of that Yaesu?
Well, we've tested it at the full 100 watts to make sure everything was going to live up to expectations. I believe Mark's got most of the channels programmed at 50. Mark had gone in and done the programming so that the pilots only have to go to memories while they're flying. And also to keep as many hands out of the controls as we can, because let's just say radio's not their primary concern. Fly. Aviate, communicate, navigate. That's the three things they teach you in flight school. Joe?
I was surprised. Aircraft, of course, I worked on military aircraft all the time. You know, like 24-volt buses, but this one had 12-volt DC bus,
Yes.
so you didn't have to do anything to get power.
Right. Yeah, the Cessnas, until you get to the next level above this one in the Cessna model hierarchy, they stay at 12 volts.
Okay.
When you get to some of the other ones, some of the Beaches are 28. Some of the King Airs, which is another version of the, are 28s. So you do have both 14 and 28 volts in the aircraft.
You were talking also about nav aids. Does anybody still use those low frequency ones, you know, like the
ADF?
kilohertz stuff? Because I know they're still on the air.
There's a few of them still out there. Anytime we do an avionics upgrade on an aircraft, it comes out.
Really?
Okay.
Because you can use AM radio as well.
Oh yeah, in fact, 90% of the time when a pilot brings an aircraft into the shop, we look at the ADF and it's tuned to 11:20 a.m. Somebody's been listening to the Cardinals baseball while they were flying. And most pilots will readily admit that. And that's actually, that ADF is the reason that through-hole was already in the aircraft on the top, because the ADF system, which is automatic direction finding, was a 2-antenna system. It had a long wire on the top from the center of the fuselage to the tail, and then it had a large module underneath. And so there was a loop antenna down there. So the phasing differences on those is what gave you the direction that you were headed. Yes?
You had mentioned that weight's a major factor for the aircraft. Do you know how much weight you put on that aircraft?
The usable load on that aircraft is approximately 1,500 pounds.
No, I mean.
Oh, we put on?
Yeah, how much weight? Because you had to manufacture something, put on the wing.
What we will do when we get done with everything, we will actually weigh the aircraft.
To recertify.
Yeah. So there's a couple of ways you can do things. You can do a moment arm weight and balance. So I mounted 1.4 pounds, 16 inches behind the zero line on the aircraft. And then you do all those calculations for levers, if you will, moment arms. They call moment arms. Or you can weigh the aircraft when you're all done. If you're only doing a minor change out, it's real easy to do that 1.4 pounds at 16 inches and do the calculation. But if you're changing 8 or 9 different things, then and they're all different places on the aircraft, then you're better off just weighing it at the end. But yeah, that I would expect we're going to put on about 10 pounds. Yes, sir.
English is the official language of the country
It is, okay.
and acts as the lingua franca of the people. Guyanese, Creole, Caribbean, Hindustani, Chinese, Amarin, American languages, etc., are spoken by the country's different ethnic groups.
Wow. Thank you. That was,
Paul, a non-technical question, is St. Louis Medical, the Hospital Zero, they the destination? In other words, the Wings of Hope, are you gonna fly to Ghana or wherever it is? Or do they fly from one place to the other, regardless of where they need to go?
within Guyana, they'll all be local.
Oh, okay.
It's from Georgetown to the villages.
So St. Louis Hospital
All we're doing is leasing the aircraft to them, providing technical support and some financial support.
What about other locations though? I mean,
So all of our mission countries are independents. They don't ever fly anything back here. For instance, we took a plane down to South America like 2 weeks before COVID hit. It took the guys 10 days to get it there. And they had to pre-stage fuel on different islands in order to hop down there. For some reason, they didn't want to fly a small Cessna-type aircraft down the throat of Mexico. I can't imagine why. Drugs or something like that, you know.
One of your early slides, when you had the list of countries.
Yep.
They were mostly South American.
Yep.
But I don't think Cambodia is in South America.
No. We have Tanzania, which is I believe in Africa.
It is.
And Cambodia. Cambodia is actually one of the outliers on our mission as Wings of Hope.
More than 800 miles.
Well, the 800 miles only deals with us personally transporting a patient
In the U.S.
in the around St. Louis, and the rest of it is financial, logistics, coordination type things we do with them. So we help them when they get to their annual. They find a rudder bearing is bad. We'll get the rudder bearing and send it to them. They call us up and say, my comm radio has died. We'll get a comm radio, or we'll work with them to troubleshoot remotely what's gone wrong with their radios, and then get the parts to them so they can repair it in the field. So I want to clarify the difference between there. The mission activity worldwide is more support and financial and management, if you will. The medical air transport, which we have our 3 aircraft here, and 206KY was one of the medical air transports at one point in time, because it is stretcher capable. But the 3 we currently fly, their mission is 800 nautical miles from St. Louis. The patient doesn't have to start in St. Louis or end in St. Louis. We'll fly to Lawrence, Kansas, pick somebody up and take them to Mayo. And then 2 days later, we'll fly up to Mayo, pick them up, and take them back to Lawrence, Kansas.
What qualifies someone to be able to use the service?
There's some medical constraints. You have to be ambulatory or close to ambulatory. No ventilators. We can't supply oxygen, but there's no auxiliary power in the aircraft for medical devices. There's a whole team that does their best to evaluate and see if we're capable of supporting the patient with where they're at in their medical pursuit.
But more my question is it based on financial need?
Zero attention to finance. They do not ask who your insurance is. They don't ask how much money you got in the bank. They don't ask any questions. All they ask is medical questions and are we able to support you in a medical need.
So is it like first come, first serve?
Yeah, I guess in a way, but we fly about 250 missions a year. So I mean, we're not shuttling people every day by any means.
Okay.
So.
One other question on the HF
Mhm.
antenna. You find that that you probably want to talk to where you're going or where you've been, but the antenna pattern is this way. Is that an issue, or do you ever have to change course to get a better signal?
The pilots have told us they've not to date on their previous work down there had a problem because really we're in the near incident vertical type range. We're in the 300 to 400 mile range.
Okay.
So we asked that question of them. You know, we don't know what the pattern of this antenna is going to look like for sure. We can estimate it,
Right.
but until we actually go out and field test it, and the question is it worthwhile field testing? Until we actually get it in the air. Once we get up and do some flight testing with it, we'll be able to give them a better clue Because I'm pretty sure if we get out on the air and we say aeronautical mobile on HF, we might have a few people call us back. And we'll be able to figure out, based upon where we're at and what our heading is, where those lobes of that antenna are from there. So, but it's an excellent question, because yeah, we asked that early on. It's like, what are we going to do about the pattern in this thing? Oh, it could be. Hopefully not literally,
Right, yeah.
because I intend to be on that plane. Yes, sir.
What does the FAA say about putting all this stuff on the plane? You gotta get approval or what?
It is considered to be supplementary to the mission of the aircraft because it is removable. We did a lot of talking about that because obviously none of this HFs here is PMA, part management acceptance, or STC's supplemental type certificate. It's not out there until you get to tens of thousands of dollars of radios. So we originally talked a lot about mounting it under the seat, so it would be really more clearly definable as removable. But the guys who are going to have to sign off on the logbooks for us putting this in were comfortable for what we were doing, that they would be able to defend their position with the FAA, that it was supplemental, it was not critical to the mission of the aircraft. And as long as we do electrical load analysis to make sure that in putting these radios in does not overburden the alternator on the aircraft, then they'll be able to sign off on it.
Is that radio ALE compatible?
I'm not sure.
So, automatic link establishment? A lot of the South American countries that use HF
Mhm.
will use basically radios that scan the bands to see which is open at the time, and that's where they listen.
I do not know the answer to that. It's the first time I've heard that question.
Yeah.
I'll have to look into that a little bit and see.
Sure.
ALE.
That I don't know if the commercial people do.
Yeah.
891 is not natively ALE compatible, but it can be used with something like Ion 2G as a software solution, and it does have the ability to flip and see.
To talk to it. Okay, thank you. Any other questions, thoughts?
Nice job.
Well, thank you. Thank you. Thank you for all the questions. Makes my job easy when the questions are coming.